Yay, we're halfway through. We did the hard part. We learned a new skill, multiplying exponents. Now we are going to just expand that a little bit more into division. So we know that multiplication and division are inverse operations. They're the opposite. So if I'm multiplying exponents, 3 squared times 3 to the 5, then I'm going to add those exponents. So I would have 3 to the 8th. If I'm dividing, then I'm going to do the opposite. So 3 to the 5th power divided by 3 squared is going to be subtracting the exponents. So I have 3 to the 3rd pair. Okay? And this is how we show that. So 3 to the 5th power is 3 times 3 times 3 times 3 times 3. And 3 squared is 3 times 3. Now, if I know from my division rules, which I learned in 3rd and 4th grade, that 3 divided by 3 is 1. So if I have a bunch of these 3's, I can cancel them out. So if I have, my mouse is not going anywhere. So these 3's, 2 on top and 2 on the bottom, they cancel each other out. So I would be left with 3 times 3 times 3. And so my answer is 3 to the 3rd power. Okay? And so basically that's it with the division part. It's just the opposite of multiplication. And we know for multiplication, if the base is the same, then we can add or subtract the exponent. So 3/5 to the 8th power divided by 3/5 to the 6th power would just be 3/5 8 minus 6, which is 3/5 squared. And it works with any fraction. Any number a divided by any number b, as long as any number a and any number b are exactly the same. So if your fraction is the same and you're dividing, then you just subtract the exponents. Works with negative numbers, everything. This is where it gets a little funky. Now, I made a big point that if the bases are different, we cannot combine these things. We cannot multiply 3 to the 5th times 2 to the 8th because the bases are different. But I can divide 3 to the 5th and 3 squared. So I'm going to split those fractions up. I'm going to imagine 3 to the 5th divided by 3 squared and 2 to the 8th divided by 2 cubed. And I'm going to do those separately. So 3 to the 5th divided by 3 squared is 3, 5 minus 2, and 2 to the 8th divided by 2 cubed is going to be 2 to the 8th minus 3. So I have 3 cubed, because 5 minus 2 is 3, and 2 to the 5th, because 8 minus 3 is 2. So I have 3 to the 3rd times 2 to the 5th. Yes, they're numbers. I could multiply them out and find one big number for the answer, but we're just learning some skills here. This last one, it looks complicated, but using everything we know in math, the commutative property, the inverse property of multiplication, all that other stuff, we can separate it out. So I have 5 cubed divided by x cubed times 3x to the 8th. Now, if I'm dividing, I'm actually multiplying by the inverse. So 5 cubed divided by x third is 5 cubed times 1 over x to the 3rd. 3 times 8x to the 8th is 3 times x to the 8th, and I can make x to the 8th into a fraction by putting it over 1. Now I can use that commutative power to combine my fractions, my x powers, my bases of x, and my numbers. So I have 5 to the power of 3 times x to the 8th divided by x third, right? So multiplying by the inverse is same as dividing. So my powers here, my x to the 8th and x to the 3rd is just going to subtract. I cannot combine numbers with the same base, with different bases, but I do know 5 to the third is 125 because 5 times 5 times 5 is 125. And then 125 times 3 is 375. So my final answer is 375 x to the fifth. And now we are almost done with this whole chapter. One more video.